Hi, in this video we're going to be taking a look at this ZIG X70 Caravan battery charger power supply. Now it's quite rusty, as you can see. So I volunteer at our local repair cafe and somebody brought this in and said it wasn't working and would we be able to have a look at it. And because I've looked at something like this before on one of my videos, I got delegated to have a look at this. It looks like it's got a couple of odd screws in here, so I think we'll start by taking those out and we'll have a quick look inside first just to see what's going on. Right, I'll remove those. Right, that's those out of the way. Let's have a look, see what we've got in here then. Right, tell you what, we'll zoom down a bit so we can get a bit closer look. Right, well, we've got a few rusty nuts and bolts just here, and there and there. It looks like we've got a resistor here that's been getting quite hot by the look of the circuit board. Looks like we've got a 5 amp fuse there, which doesn't look blown to smithereens, so that's a good sign. Right, okay, I think I'll get the meter out and we'll just check that fuse first. I mean, this hasn't been plugged in for quite some time, so it should be safe to work on. Now, when you're working with me and stuff, always be very careful. I'm not an expert and you might be advisable to copy what I do, just in case I do things that may be unsafe or hazardous to your health. So let's just see. Right, so the fuse is fine. So I would think from the fuse it then comes to the bridge rectifier, which is just here. So let's see if we get continuity from the live going to one of the pins on the bridge rectifier. Yes, we do. Right, so we should have the neutral going to the other pin on the bridge rectifier. Yeah, we're getting a bit resistance through these components here, so that's fine. Let's just check if we've got a short across the live and neutral. Now we shouldn't have, because otherwise the fuse would be gone. So that's okay. So I would say the bridge rectifier is okay, because normally when these blow, they blow short circuit. We can check the diodes on the bridge rectifier. If I go into diode check, and if we go from the AC input to each leg, we shouldn't get a reading one way. And then if we swap the leads around, we should get a reading now. I don't know if these have got a coating on or not, or whether they're just corroded. There we go. And we shouldn't get anything that way, but we should get a reading from there to there, so those diodes are okay. If I swap the leads around now and go on the AC input on that side and then go to, there we go, and if I go on to the other AC input, right, so all the diodes are okay in the bridge rectifier, so that's fine. So where next then? Well, I think we might just power this up just to see what it's actually doing. I mean, on the label here it just says dead, but some people's interpretation of dead aren't quite the same as mine. Let's see if we can get this so it doesn't blow up all over the bench. Right, so I'm going to apply some power to it now, and I'm going to keep my fingers well out of the way of it for now, and we'll just see what it does. See, if there's a little LED light just down here, so Well, I don't know whether the microphone picked that up or not, but it kind of made a bit of a squealing sound, and then as the power discharged, the squealing sound sort of dropped off. So to me, I would say it's oscillating, but I don't think it's giving any power out. I think we're going to have to take this board out and have a look at it. I think that's going to be the best course of action. So it looks like we're going to have to unbolt, or try and unbolt all of these rusty screws here to get this board off the heatsink. Yeah, because it's riveted here and here, so we can't remove the heatsink with the board, not without drilling the rivets out. So I'm going to have to remove those 4 screws instead. It's a bit of a nightmare, isn't it? Right, okay then. Now there may be some charge in these capacitors here, so I'm going to have to proceed with caution doing this. Right, back with some long nose pliers. I think I might take these leads off so I can get in a bit better. Get that out of the way. Ah, you still can't get this off. I'll just show you why. I'm going to have to drill those rivets out because the board is screwed in from underneath into this aluminium heatsink. So even though I've unscrewed the bolts holding the transistors to the heatsink itself is riveted to the external case. So I am going to have to drill these out. Well, that's a pain. Right, I shall go do that and then I'll be back. Right, the drilling is complete. Let's remove these 2 screws and hopefully we can get this board out now. No, there's another screw on the bottom. There we go. Right, so I'm just going to put that down. Careful not to touch the bottom. And the first thing I want to do is check to see if there's any voltage in these main capacitors, which are just here and here. So I'm going to volts DC. .2 of a volt. 0.2. Right, so that should be fine to work on now. Right, so I don't think the fault's on this side of the board at the moment. Could be wrong, but I'm hazarding a guess it's more on the output side. Tell you what we should do. Let's just see if there's a short on the output or anything. Right, so it's a bit hard to see here, but no, that's a bit not the best as well. So these must be the ground. Like about 120 ohms there, we wouldn't say it's short. We've got some output, we've got some rectifiers here on the output. Let's just see what those measure. Well, I think those look okay. Let's try that one. Some of these things it's hard to tell when they're in circuit. You're best off removing them just to double check. On the last unit that I looked at that was similar to this, it was actually this IC here that had failed, the switching IC. It looks like this one's got an extra IC here. I don't know what that one is. Let's zoom down, see if we can see. Let's look and see a number on that one. It's an LM358. So I think that's an op amp if I remember. There's a bit of a crusty resistor under there. Just here. This doesn't particularly look the best. I can see a brown on it, so I'm not sure what the rest of the values are, but there might be black there. I'm not sure what colour. I'm not sure what colour code that is. It's a bit hard to see what's left of it anyway. Let's see if we can see anything else on this board. That looks obvious. And that resistor there looks a bit crusty as well. Let's have a look at the other side of the board. Actually looks better than what I thought it was going to, this. Looks almost like that track's nearly eaten through. I'm just going to clean this bit up here with a bit of IP and a brush. So we can have a look. It looks like there's been a connector pulled out of there. Yeah, just here. It looks like there should have been another one of those connectors in there, and that's been pulled out. That looks like a current shunt for measuring the currents. But at the moment there's nothing jumping out at us to say, oh yes, that's the fault. It's hard to tell whether there's some leakage from these capacitors here. Actually I was thinking more there, but this is that brown glue that I encountered on the JVC Hi-Fi, I think, which is known for causing problems, especially when it gets wet. I think because it becomes conductive. Right, well the only thing I can see that's kind of standing out at the moment is possibly that resistor there, and maybe that resistor there. Okay, so I'm going to move this wire out of the way, see if we can get access to that resistor down there a little bit easier. Right, let's see if we can get it out with the iron. It looks like it goes from there to there. Right, let's see if we can work out what resistance it's supposed to be. Well, it looks like green, brown, brown. So what's that, 510 ohms? It's measuring more like 570 that. I don't think I've got any replacements of that value. So I've just been looking at the resistor under the little spyglass here, and the last colour is gold, which is 5%. So if this is 510 ohms, at the most it should measure 535. And and it's measuring 580 ohms. So it's about 35 ohms out of tolerance, so I don't think that would make a huge difference. And I've just checked my old circuit boards that I've got lying around to see if I had a one of the same value, but unfortunately I haven't. And the resistor kit I've got is only 1/4 of a watt, where this is a 1/2 watt resistor, so I think I'll put that back in for now. I may order a replacement one, but I don't think that that's the problem. Right, so I've just popped that resistor back in there. Let's see what this one is. So we've got yellow, purple and black. So 4, 7 and 0 zeros. So 47 ohm. And 46.9. So yeah, that one seems to be measuring okay. I think I might power this board up and we'll check some voltages on this IC here, and that might give an indication of what's going on. So I've looked up the data sheet and the pinout for the KA7500B, and I've just printed out a copy here. And pin 7 is ground and pin 12 is the supply voltage, and it takes between 7 and 42 volts. So what I'm going to do, I'm going to power this up, and I'm carefully keeping my fingers well out of the way of any live parts. I'm just going to probe on the chip and we'll measure what voltage is going into it. So I'm just going to power this up now. Right, and this is live. I can hear it doing something. So if I go on the second pin up here, and the fourth pin up on this side, 1, 2, 3, 4, should be that one. And we've only got 4.6 volts going into this chip. I'll just do that again. Yeah, so the supply voltage going into the chip is only 4.6 or 4.7 volts, and it's supposed to be between 7 and 42 volts. So I think that could be the problem. Right, I'll just give this a moment just to fully discharge, and then we'll have a look at the bottom of the board and see if we can trace where this chip gets powered from. So pin 7, 1, 2, 3, 4, 5, 6, 7 is the ground, which is this one here, and I think that should go to here, which is the ground. So that one's okay. Now the power supply comes in on pin 12. So 9, 10, 11, 12. So this pin here. That seems to go to here. And then I don't know if that's a resistor or something, straight across. Right, okay. It seems to go to here, which has got a resistor that goes across to there. I'm not sure if that's right, I'll have to have a look at the colour code on it. And then I think this is one of the outputs. Actually no, that one's marked LED drive. So this one drives an external LED to tell you the status of the power supply. So I guess that must be fed off the voltage that powers the chip then. Right, so it must be going this way then. It looks like we've got a resistor that goes from here to here. 22 ohm. And then that goes to that resistor that I've just had out. interestingly enough. I don't know where that pin goes. That goes to another resistor on the other side that goes across to this point. Is there anything else wired into this? It looks like it also goes here and to here. Let's see what we've got on this side. Well, it looks like we've got a couple of capacitors. I suppose we could have a capacitor problem on it. I don't exactly know how it regulates the power supply. I've checked the capacitors already just to make sure that they were discharged. Let's just try some of these diodes, just in case one of those is shorted. And there's actually a few just down there as well. Might be a bit hard for you to see. Well, that one's alright. That one's alright. There's another one here. There we go, that one's alright. There's about 3 under here. I'll just see if I can get the probes on. That one's okay. That one's okay. That one's okay. Let's pop these capacitors out. Let's have a look at those. I mean, it could be that this chip's failed internally and it's pulling the voltage down. Let's just check the resistance between power and ground. Well, it doesn't look like the chip's shorted. Let's take this capacitor out and we'll have a look at that. So it's this one here. What's this? 4.7 microfarads, 50 volts. I don't think that looks right. Right, let's just compare that to a known good capacitor. Because that ESR, that looks a bit high, I think. Let's just try another one. Just to compare. Well, that one, the V loss, it says 0.6% and the ESR 1 ohm. Let's just try this one. And this one, V loss 2.8% and 2.48 ohm. So I might just change that just in case. Let's just pop a new one in. So I've just been trying to work out again where the power actually comes from for this IC. And I know it was like the 4th pin up here. It went through a resistor. And then if we follow this track, it goes through another resistor to here, which goes to that resistor that I already had out. But also, there's a capacitor here that we haven't had out yet. This orange one. So, I'm going to take that one out. Right. Oh, well that doesn't look too good. Now that looks a bit crusty, doesn't it? So what's that? 47 microfarads, 50 volts. Now either looks like corrosion or that capacitor's leaked. Right, let's get the component tester out then. Let's see what this measures. Oh, perhaps I haven't got it in quite right. I'll see if I can find me little leads just to clip on, because I think these leads might be a little bit short. 6 picofarads. Well, I don't think that seems right, does it? I think we might have found it. So I need a 47 microfarad, 50 volts. Right. I shall be back once I find one of those. Right, so unfortunately I couldn't find a new one, so I've had to pull one off the board there. So it's the same voltage and the same capacitance. Let's just see if this one measures okay. Yes, 45.6. Right, let's pop this one in, and then we'll see if that sorts it out. But I'm more optimistic now. Let's get that soldered in. Right. Let's see if that's made any difference. Right, I'm just going to plug it in just now. I think that's it. I've got a power light on. It's making a buzzing noise. Let's see if we've got anything on the output. The voltage doesn't look right though. It's definitely better than it was. Let's just see what voltage we've got on that IC now. Well, that's better. Well, it looks like we've fixed one problem, but I still think there may be another problem on it. So I think I'm going to take most of the capacitors out with this just to check them. Let's see, there's one just at the front here, so we'll take that one out. And again, that one looks rather crusty. I'll just zoom down. Let's just see what that one measures. And this one's supposed to be 100 microfarad. But it's measuring 253 with a... Yeah, that definitely doesn't look right, does it? Right, I'll change that one then, so I need 100 microfarad at 50 volt. Right, I don't appear to have any new ones of those either, so let's try this one. Let's see, I just pulled this one off an old board, so let's see if this one measures okay. Well, that one's a little bit down. Let's just give another one. Right, so that one measures okay, so we'll put that one in. Just clean these holes out. Yeah, I'm just going to clean that side of the board up with a bit of IP as well. Just get rid of some of this crustiness. There we go. I wonder if it's worth taking these ones out. These two big smoothing capacitors, which I think is there. Let's pop one of those out and we'll have a look at one of those. Those actually don't look too bad. And 2200 microfarads, or 2200. Let's see what these ones measure. Yeah, that one seems okay. Right, we'll pop that one back in then. Just clean them holes up again. Just in case you didn't know, on the circuit board here we've got this black area. Well, that denotes the negative, and that's the negative on the capacitor here, denoted by the white stripe. Because if you put them in the wrong way, they tend to explode. Because you get rather hot first and then explode, so not the best idea. There we go, that's back in. Let's give these bits a bit of a clean up. I think I might just give this a test again just to see if those capacitors have made any difference now. Let's give this a whirl again. Right, fingers out of the way. And let's just power this up again. Still don't like the sound of that buzzing. I've only got 2.7 on the output as well, so I've still got more problems. Well, I've checked all of the transistors, I've had those out, I've checked all of those. I've checked all of the capacitors, I've actually changed those two. I've checked this capacitor here, I've checked this one here. And I've also had the two main smoothers out and checked those, and all of those seem fine. I've checked all the diodes, all those seem fine. So I'm beginning to wonder if it's this IC. I know the minimum voltage that this IC works at is supposed to be 7 volts, which is what we have. And the third pin down here is supposed to be a 5 volt reference. Now if I just connect it up, let's get the meter in shot. I'll just plug it in. Now if I go on the ground pin, which is the second one up here, and I go on the third pin down, which is the voltage reference, we're supposed to have a 5 volts, and we've only got 4.8. The power into the chip is this pin here, and it's over the 7 volts. So why have you only got 4.8? If it's a reference voltage, I would have thought that would have to be 5 volts, not 4.8. I've also traced through the circuit a bit. These two pins here are the emitters of the transistors that control the output of the chip, and this is the collector on one output and this is the collector on the other output. And what those do, they come up here and drive these two transistors here, which have got diodes across them for back EMF, and that is what drives this transformer here, which then drives the two main switching transistors over here. So kind of suspecting this chip. So what I'm going to do, I'm going to remove this chip. Now this is a KA7500B, which when I've looked are obsolete. So what I have found is that there's a TL494CN, which is one of these here. So what I'm going to do, I don't know whether this one's actually working or not. It's just I pulled this one off an old power supply a while back. So I'm going to try this one in here and then we'll see what that does. Right, so I'm going to unplug this. I'll get this out of the way. And then we'll start removing this IC. And I'm putting a socket in on this one, so I should just be to pop that in like that. and then solder this back up. Right. I'll just give that a little bit of a clean up there. Right, let's see if that's made any difference. Right, so that sounds pretty much the same, so it doesn't appear to be the IC. So I just thought I'd get the thermal camera out just to have a look to see if I could see anything going on there. And notice that capacitor that I changed seems to be getting a bit hot. I mean, not hot compared to, you know, anything excessive, but it just seems to be heating up compared to all of the other components on the board for some reason. So I've spent the last couple of days working on this, and I think I may have eventually found the problem. But I'll tell you what I've done so far. I've replaced this op amp, just in case it was that and it didn't make any difference. I've changed these capacitors, these ones. I've replaced that one again with the low ESR one, just in case that was the problem. I've took all of the transistors out. I've checked all of those are fine. I seem to understand this circuit a little bit better now. What happens is there's a diode down here, which is a rectifier diode, and that goes through this resistor here, and then there's a Zener diode here, and that feeds the power supply to the chip. So that's what that bit of the circuit does. Let's try and zoom down a bit so you can get a better look. So this chip drives these two transistors here. We've got diodes across them, and that's what drives this little coil here, which then drives the two main outputs there. We've got two capacitors here. This one and that resistor determines the oscillation frequency of this chip. And if you put the scope on there, I think we're getting about 60 kilohertz. So I know that bit's correct. But when I measure on the output here, we're still only getting 3 volts. So I thought, well, have we got a short on the output? So I'll just get the test meter out. I'm just going to ohms. And if I measure the output here, we seem to have about 150 ohms. I thought, well, it's a bit unusual. I would have thought that would be a lot higher. I mean, you know, why have we got 150 ohms? So what I did, I thought we'll try putting 12 volts onto here on the output, and we'll see if anything heats up or if anything gets hot or what it actually does. See if we get the power supply voltage to the chip. And what started to happen was the resistor here started to get hot, and that's 120 ohms. I mean, I did check all the diodes and everything previously as well, and they all seemed okay. So I traced through where this resistor goes to, and it actually goes to this diode here. Let's see if I can get there in shot a bit, which is marked ZD2, so I think that's a Zener diode. I'll just zoom back out a bit, and if we measure this diode here, if I go on to, let's see, diode check, we have a short. Now I'm fairly sure I checked all these diodes before. I'll have to have a look back at the video. So perhaps I've missed this one, or that one's blown when I've replaced some of the capacitors or something, I don't know. So we'll get that diode out, we'll have a look at that. See if we can figure out what Zener diode it is. And I think we'll replace this resistor here. Now this did have a bit of a scorch mark on it beforehand. I did notice it was a little bit browning on the middle of it. So there's probably been a combination of problems on here, I think. Like I said, those capacitors were faulty. And I think that diode as well. I think the ICs were actually okay, but you know, we've just changed them just to try and rule it out. So right, let's get this diode off then. Right, let's get these wires unplugged. And I've also noticed, it seems like one of these transistors isn't switching properly, because one of the capacitors has got a lot more power in than the other one usually. It's usually this one has still got quite a bit of power in. They're 34 volts. And this one hasn't got any in. So I think it's that transistor there isn't switching properly. And when I looked at the output waveform of this chip, one of them was a lot higher than the other. I might actually get the scope hooked up and I'll show you exactly what was going on with this chip, and I'll show you the oscillation on the oscillator pin, and I'll show you what's happening on the output. Yeah, I think I'll do that. I'll connect the scope up first and then we'll take that diode out. Right, I've got the scope hooked up. Now, if we were to put the scope probe onto the right hand side here, that would be pretty disastrous because it will probably blow the scope up, because this is mains. But from this side, it's actually isolated through the transformers, so we're okay hooking the scope onto this side of it. So I'll just zoom down a bit, and we'll just go onto the oscillator pin first, which is the fourth one up here. So we'll go on there, and if you look at the scope there, you can see the waveform. And we've got about 63 kilohertz. So that's what we're getting on the oscillator of the chip. Right, we'll just try and adjust for the outputs here. I don't think that's right, that output. And if we go on to the other one here, again, so I don't think the chip's getting enough power, and I think there's something dragging it down, and I'm fairly sure it's because we've got a short on that diode. Right, well, I thought I'd show you what was happening on the scope first, so we'll get this switched off and then we'll take that diode out. There we go. Let's just double check that out of circuit. Right, that diode's definitely gone. Now let's see if we can see any markings on it. Right, let's see if we can see any markings under the microscope. I can see a 15 there, I think it is. And a number 2. Right, I'll have to look up, see if we can figure out what that is. I mean, it says Zener, so is it a 15 volt Zener? That might actually make sense thinking about it, because if the supply, I would have thought it's going to be about 13.8, so it's going to be below 15 volts. So perhaps this is some kind of protection that blows if the voltage goes above 15 volts. Right, I'll see if I can order one of those then. And that's the 120 ohm resistor, which I've just removed as well. As you can see, it's a bit scorched in the middle there. It actually still measures not too far out of tolerance, believe it or not, but I'm going to replace it in any case. So right, so it's the following day and the diodes just arrived. I ordered this pack of diodes off Amazon. I think it was only about £5. I'll leave a link in the video description, along with the other tools that I use, like the blue mat and, you know, other bits and bobs there, in case anybody's interested. So we'll pop this diode in, and then hopefully we'll see if that cures the problem. Right, we'll just snip off those excess legs. Right, let's get it hooked up yet again. Right, zoom out a fraction. Right, let's power it up. So I'm just going to power it up just now. Oh, well, it's not buzzing. And I can see a green light just there. I'll just turn the big light off so you can see. There we go. Right, let's see what we've got on the output now then. $14.2. Well, that's about right, you know, 13.8, 14.2, it's, you know, it's not far off. Like you say, this is supposed to charge the Caravan battery up. Right, I think what we'll do is we'll try a load on it first, and then we'll put it back in its case, and then we'll wrap up. So see if I can find a suitable load. Right, I found an automotive bulb, so we'll just connect that up. Just with a couple of crocodile clips here. Oh, there we go then. Right, I think we'll put it back in the case. Right, I've replaced those rusty bolts in there and put some new screws in here just to hold that plate on where we drilled the rivets out. So I'll just hook this back up and get the lid back on, and I'll just give it a quick final test, and I think that should be we're done. Right, I'll switch it off. I'll just go on to the output again. That's my little bulb. Right, we'll plug it in. Yes. Right, so all up and working. Well, I spent about 3 days in total on this trying to find out what the problem was. Like you see, we found a number of problems with it, but it seems like I missed that diode. I did check all the diodes, but I must have just missed that one. So unfortunately it took a lot longer to actually repair than what I anticipated. But it's quite good in one way, because I've learned a lot about the IC in this device, the TL494 I think it is, or the KA5300B. It's quite an interesting chip, so I've actually learned a fair bit. So, you know, all good at the end of the day. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.